So, hello everyone. So, this is our first lecture in the DCN lecture series. So, we are covering the topic IP addressing. So, let's start with the basics. The concept of addressing. So, addressing in networking refers to assigning a unique identifier to devices. Like we have been using internet from so long. When we go to the properties of our LAN connection, then we can see there that what is the IP of our device at that particular time. And there are multiple settings in that. Automatically select a IP, or there can be fixed IP as well. So depending on those, we have seen that any device which is on an internet connection must be having a logical address. That logical address is termed as IP address. And in addition to this, there is also a machine address, which is device specific, and this is network specific. So this is the basic difference. So without going into the more details of this machine address and logical address, I am straight away jumping to how this logical addressing is performed in various classes. So this is the method used to assign unique numerical identifier, which is termed as IP address, to each device on a network that uses the internet protocol for communication. That means any device which is communicating over an internet connection with some another device, so both the devices which are communicating with each other must be having a unique IP address. So an IP address serves two main purposes. First one is identification. That is, it uniquely identifies a device on a network. And then location addressing. It provides the location of the device in the network, enabling data routing between devices across networks. So first thing is locating that device within the network, and whenever a device external to the network wants to communicate with that network, so other networks can also identify, or the devices from outside that network can also identify the same device using the IP address. So these are the characteristics of IP, Internet Protocol. So it is connectionless, best effort delivery. That is, there is no guarantee that the intended message will be delivered or not, but there is best effort in delivering the message. Unique addressing, routing support, fragmentation, and hierarchical structure. So these are the some characteristics which an examiner might ask in the exam. What are the characteristics of IP? So these are all the characteristics of IP, and particularly there are two different types of IP, IPv4 and IPv6. So right now we are generally using IPv4, and it is sufficient for the scenario applications of the current scenario. But when we will be moving into the IoT era, where every single thing will be connected to the internet, then in that case IPv4 will be falling short of the addresses, and then in that scenario we will be moving towards IPv6. So now let's start with the basics of IPv4. Okay. So in addition to physical address, NIC, to identify each device in the network, it requires an IP address that identify host of its network. Okay. So which host we are targeting inside a network. Then an IP address is 32-bit address for in case of IPv4, and in case of IPv6 it is 128-bit for IPv6. So IP addresses are unique and universal. It is represented in dotted decimal notation. Dotted decimal notation means there are 4 components, and each decimal component can be written in 8 bits of binary. 8-bit pattern, another 8-bit, another 8-bit, another 8-bit. So the machine is going to understand the IP in segments of 4 8-bit patterns. But for humans, it is not possible to remember such a long string of binary numbers, that is 110 kind of string for 32 bits. So it is convenient for us to use decimal notation, because decimal is something which we have been using from our childhood. So we are very much comfortable with decimal. So we can simply write these numbers into decimal. Okay. So if we are provided with these IP notations, then we can simply write the decimal notation of these IP addresses by converting this binary number into decimal. And for performing this conversion, rather than going for the proper method based conversion, we can use a shortcut of the weights. Like this is 2 raised to power 0, that is weight 1. This is corresponding to weight 2, which this is corresponding to weight 4, 8, 16, 32, 64, and this one corresponding to 128. So we can see that there is a 1 at weight number 128 and weight 1. So this becomes 128 plus 1, 129. Okay. So this becomes 129. Similarly, this can be 1, 2, 4, 8. So 8 plus 2 plus 1, 11. Similarly, this again 1, 2, 4, 8. So 11. And here 1, 2, 4, 8, 16, 32, 64, 128. So all these are going to add up to 255. So out of this, weight number 16 is not there. So 255 minus 16 becomes 239. So this is 239. Similarly, we can convert this address also into dotted decimal representation. Like these are the solutions. So this you can take it as an exercise and you can verify whether you are getting this answer in decimal dotted representation or not. Okay. Similarly, we can perform the reverse part. That is, we may be provided with a IP address in dotted decimal representation and we are asked to convert this into binary. So if we want to convert this, then again we can use the same set of weight 1, 2, 4, 8, 16, 32, 64 and 128. So to have 128, definitely 128 would not, for having this triple one, we would not be requiring this. Then 64, then 64 plus 32 becomes 96, and then 96 plus 16, it will cross, so I am skipping it. 96 plus 8, that becomes 104, then 104 plus 4, 108, then 1 plus 2, 110, then plus 1, 111. So this is 0. So this trip 111 is represented as this in binary. Similarly, we can write for this 56 and 45 and 78, writing each decimal number in 8-bit binary representation. So this becomes the binary notation of the same IP address. So this is mentioned here. You can check. This is the same answer as we were expecting. Okay. Similarly, we can write for this 56. This is the corresponding 56. This is corresponding to 45, and this is corresponding to 78. Okay. Now, by looking at an IP address, we can very easily tell that this IP address belongs to which class. That means there can be classful addressing. Classful addressing means each IP address, all the IP addresses are subcategorized into different range depending on the first byte of the IP address. So if in the first byte, first bit means MSB. If it is 0, then it is class A. That means if we look at the weights, That means this is 0. That means IP, this complete thing, can maximum be equal to 127. So any IP address which is between 0 to 127 will belong to class A. Okay, 0 to 127. This 0 is signifying that any number between 0 to 127 will be having a 0 in front, so it will automatically belong to class A. Similarly, 10. By 10 we mean 128 is there, but 64 is not there. 128 is there, but 64 is not there. That means 255 minus 64. We will have 5 minus 4, 1, 25 minus 6, 191. Okay. So any number between 128 to 191 will belong to class B IP address. Similarly, 110. Okay. That means in that case 32 won't be there. Similarly, for class D, 16 won't be there. And class E, all 4 bits will be 1. So we can summarize it like this. So any IP address between 0 to 127 will be having 0 at the MSB position. Similarly, 10 at the MSB position results in this range. Similarly, 110 in the MSB, 3 MSB positions results in this range. Similarly, 1110 in the MSB position results in this range, class D. And last one, 4 ones in the MSB will result in this range, 242, 255. So these are the range of various classes of IP addresses. So we have summarized it like this: 0 to 127, 128 to 191, 192 to 223, 224 to 239, 242 to 255. So the starting address will be 0000 to 127 dot all last 3 segments. Remember, class A has 4 8-bit segments. So first 8-bit segment can be 8 zeros to 8 ones. Okay. So this 8 zeros means 0 and this 8 ones means 127. And these remaining 24 bits can also be 24 zeros to 24 ones. So if these are 24 zeros, then it will be 000, and if it is 24 ones, so it will be 255.255.255. Okay. Similarly, for class B, we can have a look. 128, 191. 128 will be the starting point, 191 will be the last IP part of the first bit, and 3 zeros, and then 3 zeros means 24 zeros in binary, and these 255.255.255 means 24 ones in binary. Okay. So this is class A is suitable for large networks, class B is suitable for medium networks, class C is suitable for small networks, class D is suitable for multicasting, and class A is reserved, which is not being utilized right now. So in general, if we look at the IP addresses in our laptops or computers, we will see that they must be starting with around 192 or 192 or more. That means most of us, we are using class C IP addresses in small networks. Okay. So find the class of each address by simply looking at this 0. We can say that it is class A, and this is 1111. So this must be class last one, A, B, C, D and E. This is class E. So class A and class E. Okay. Similarly, we can find the class of each address here also. 227 in the binary notation. 227 means it is lying between this range. So it is class D. This is class D. 252. So 252 is lying between this range. That means it is class E. 134. So 134 is lying between this range, 128 to 191. That is, it is class B. Okay. So in this way, we can find that an IP address belongs to which class. Okay. This is the simple one, or we can convert these numbers into binary and check the MSPs like we have done in this case. Okay. So this, which I taught in the beginning, that when we open our laptop and check the properties of our internet connection, then we are provided with an option to choose the IP address automatically or enter it manually. So manually entering the IP address means it will be static and it will remain same as long as you are on the network. And even if you exit the network, you turn off your device and reboot your system, then the same IP address will be automatically allocated. But in case of a dynamic IP address, when you are on a network in powered on mode, then you will be provided IP address by the network. And once you turn off your device and then restart, then there is a possibility the IP address which will be assigned to you after rebooting the system will be different one. So this is dynamic allocation of the IP address. Okay. So these are some basic differences between the static IP addresses and dynamic IP addresses, which we can cover from examination point of view. So these are manually configured, that means by the user, and this is done by the server. It always remains the same. It varies in every connection. Server, printer, remotes, access, hosting, website. So in general, whenever there is a LAN connection and there is a single printer which is being shared by multiple devices, so it is what would be beneficial to have the static IP address or dynamic IP address. So in that case, static IP address is preferable because once it is known to every user on the network that this is the IP address of the printer, so any print command can be sent to that printer for as long as that IP address is associated with that printer. But let's suppose if that IP address gets changed, then it might not be possible for other users on the network to be aware of the IP address change. So in that case, the print command might not be possible to reach that printer. Okay. So a static IP address may cost extra with the ISP. ISP means Internet Service Provider, and dynamic address is the default mode. Network automatically assigns you with an IP address. So there is no such costing related parameter related to this. Now this is the most important thing. In these three classes which are being prominently used by us or the network providers, class A, class B, class C, the first octet, first 8 bit belong to the network and the remaining 24 bits belong to the host. That means there can be 2 raised to power 8 different networks and 2 raised to power 24 different hosts in class A. 2 raised to power 24 is a very big number. So that's why it is suitable for large networks. That means in every network there are thousands and lakhs of hosts or devices which may be requiring interconnection between themselves. Similarly, for class B, there are 16 bits of network and 16 bits of host. That means there can be 2 raised to power in class B, 2 raised to power 16 networks can be there, and 2 raised to power 16 hosts can be there. By when we are saying host, that means 2 raised to 4 independent individual devices. Okay. Similarly, class C, for small networks, these are medium networks, and class C we can simply see in class C 2 raised to power 24 are the networks and 2 raised to power 8 are the hosts. Okay. So this is the bifurcation of the IP address into host part and the network part. So examiner can also ask us to fragment the IP address into two parts, which is the host ID and which is the network ID. Okay. So if we want to extract the host part, for class A, we know that it is only the first segment. So 255.0. all the host portions are converted into 0 and all the network portion is converted into 1. So by this we can obtain a subnet mask. And how this subnet mask, what is the concept of this subnet, we will be covering in our next class how this subnetting is helpful. Similarly, for class B, there were two 8-bit segments which were carrying the network part. So there are 255 and two 8-bit portions were carrying the host ID. So there are 2 zeros for the host part. Similarly, class C was having the 3 parts in the network side. So 255 and this 0 is the host part. And this is simple notation in the prefix. How many ones are there in the IP? So for class A, the subnet is simply, rather than writing this larger 255.0.0.0, we can write it as it is having 8 ones. 8 ones means first 8-bit segment. Similarly, class B means 2 8-bit segments are 1. Similarly, 24 means 3 8-bit segments are 1. That is 255. Okay. So this is the bifurcation of the IP address into host and network. And there is a possibility that classless inter-domain routing, if there is a possibility that we might not be referring to any class and seeing an IP address as simply a plain address in the complete entire network existing in this world. Okay. So in that scenario, we are not dividing it as class A, B, C, D, E. We are simply considering how much part of the network out of the 32 bits, how much part belongs to the network and how much part belongs to the host. So any part that belongs to the network will be considered as 1 and any part which belongs to the host can be considered as 0. So this CIDR notation, classless inter-domain routing of /28 means 8 ones, 8 ones, 8 ones, 24 ones are there and this another 4 set of 4. That means 28 ones are there. That means these 2 raised to power 28. 2 raised to power 28 networks are there and only 4 bits are left. That means in each network there can be maximum 2 raised to power 4 hosts. Okay. So this is the concept of classless routing. Okay, in which there is no A, B, C, D concept. And another important thing which will be useful in subnetting, which we will be covering in our next class, is all zeros in the host part and all ones in the host part. These are the prohibited addresses. That means, let's say if we write a number from class, let's say we take class B. So any number between 128 to 191 in class B. I'm taking example of class B. So 128 onwards dot, another part is there 26. So this is the network part, because class B first two 8-bit octets are representing the network, and then next two 8 bits all zeros. That means 3, 4, 5, 6, 7, 8. That means 128.26.0, sorry, dot 0 dot 0. So this is the address of router of this network. So it can't be allotted to any host. Okay. Similarly, all ones 128.26. That means 128.26.255.255. This is reserved for broadcast. If any user in the network want to broadcast any message to all the devices on the network, then in the destination address, instead of mentioning the host ID, there has to be all ones. So when the network sees that there are all ones in the host, that means this message is to be sent to all the devices in the network, and it is not belonging to any particular host. So that's why again this also cannot be allotted to any host. So all zeros and all ones, they cannot be any host. Okay. So this is the basics of IP addressing. So in the next class, we will be covering the basics of subnetting, how we can break a large network into smaller subnetworks. Thank you very much.